Hey, welcome to the MatterHackers Podcast. I'm Dave, and today we'll be sitting down with Nisan to talk about the Wazer desktop Waterjet cutter.
Hey, thanks for joining us, Nisan. How's your morning going?
It's going great. I'm happy to be chatting with you.
Yeah, well, we're excited. I think, for this podcast specifically, we got a lot of people that are into 3D printing and have a lot of context about 3D printing and how that it is a piece of digital fabrication or digital manufacturing technology. And Wazer to me is like the coolest thing to add to when I think about it as like adding it to my shop to expand your capabilities in digital manufacturing. So thanks for joining us.
Yeah, of course. Yeah, really excited to be here. And, exciting to have this new partnership with MatterHackers. And I think it's a great fit, and I see MatterHackers kind of on the forefront of this trend of you guys started out as experts in 3D printing, but over the last couple of years, I've seen that you guys have grown your portfolio beyond 3D printing to be all encompassing of digital manufacturing, and that that's where we fit right in there, kind of as a unique sort of quadrant of digital manufacturing. I sort of see like Waterjet, laser, CNC machining, and 3D printing as kind of being the sort of four key quadrants covering, complicated three-dimensional shapes versus flat shapes, and then soft materials versus hard materials. And waterjetting is kind of unique in that ability to cut hard, flat sheets, which is really useful for a lot of things. Most of the world is made out of sheet metal, so
certainly adds a new flavor to the things that we offer. Anytime we expand our portfolio into new, again, I think that like the digital is the key wrapper of all of the things that we like to offer as hardware. Is that you're going to need to hack away at the computer for a little bit to get your physical part, and some machine's going to help you make it. So, like I said, the Wazer is so cool to add that to our portfolio. We're very excited, and we've already seen some great traction a few months in, and we look forward to just opportunities to double down on that and support the Wazer brand in any way we can. So to start off, it's easiest like, who are you? What's your background? How did you get into digital manufacturing? And then how did Wazer come to be?
Yeah, totally. So I'm the co-founder and CEO of Wazer, and we started the company about 6 years ago, but the origin story dates back a little bit more, depending on how far back you want to go. But I studied mechanical engineering at the University of Pennsylvania, and I was really into design and manufacturing. So I took all of the courses that were available in that realm and spent a lot of time in the machine shop. And so I became very familiar with digital manufacturing, and specifically CNC machining, CO2 laser cutting, and 3D printing, 3 out of the 4. But when it came time to be prototyping anything in sheet metal, Pet engineering, the machine shop did not have a good solution for that. So it was actually my undergraduate senior thesis project, myself along with 4 other students, where we said, hey, let's try to build a small waterjet for the university. And that way, the students could have the ability to make sheet metal prototypes, sheet metal robots, and other things. And so that's what we did. And so we built the original prototype in 2012. And I always felt that there was an opportunity for this to be more than just a school project, but I wanted to get some experience as an engineer first. So I worked for a hardware startup company for a couple of years, got some experience as a product engineer, and then in 2015, so a few years later, I quit my job, partnered with my co-founder Matt, who was also from Penn Engineering, and we started the company together.
Nice, all on a senior project from the school. That's really cool to hear.
Yeah.
I had a few friends who did the same type of thing in CNC machines, but I think it was just like 6 years too early. Nothing was cheap enough at that level. It was probably 2006, 2007 to turn into any of the sort of hobby level stuff. But that's really cool to hear, even that those 5 or 6 years difference from when I saw it happen. That it's also Kickstarter came to be. How did the Kickstarter land treat you guys?
It was great. It was a big success and a key piece of getting us off the ground. So we basically built the looks like works like prototype in about 9 months time. So from January to September of 2016, and launched a Kickstarter. We did 1.3 million in the Kickstarter campaign. So it confirmed the interest initially, and then also, certainly provided a lot of capital for us. We set a goal of $100,000, which we knew was way too low, obviously. And 1.3 wasn't fully enough, but it was certainly enough to keep us going. So that was great. And timing is everything, and we were very fortunate. So 2012 was when I did the senior project, and then a couple years later, so 2015. So that's like right on the, riding the wave of, first MakerBot and Formlabs and others. So that was also part of my instinct of like, oh yeah, there's opportunity here. And part of the story is that sometime in the middle, like I think it was 2013 or 14, Hackaday found out about our school project and wrote a blog piece about it, and featuring a video that one of my student partners had made, a YouTube video that he had just made for fun. And they, without even talking to us, so we had no idea that they did this, and the only reason we found out was that we had hundreds of people email us saying, hey,
an influx.
I need one of these. Yeah, can you build this? Can you commercialize this? And that was one of the first things that Matt and I did, was we actually followed up and spoke to several dozen of them. And then we learned that it wasn't just engineers. So, we came at this from like the mechanical engineering side of things, which is the sort of the traditional entry into digital manufacturing and recognizing the need for rapid prototyping. But we also heard from, and we heard from people like that in that space, but we also heard from people like glass artists, for example. And we had just no idea or no exposure to this, and didn't realize that, wow, like, there are glass artists out there, and they're still scoring and breaking and cutting and grinding every single piece of glass they make by hand, and there's no digital tool that can do that. So this could be really cool for them. And similarly in ceramic and stone as well, is just like really beautiful materials that, are part of our everyday life, and that are still, there's really no other digital tool that can process them, that can cut with them, other than a Waterjet.
Yeah, that's pretty crazy. To back up a little bit, like, what specific problem were you out to solve by launching the Wazer, the desktop Waterjet machine?
Yeah, so the ability to make custom parts in hard, flat material. So I like to start with sheet metal is by far the most common material that customers use Wazer for, primarily aluminum and steel.
Sure.
Both stainless and mild. And so, it's in many ways, it's the same problem that 3D printers have solved. The ability to rapid prototype, to iterate faster and produce your parts in-house and not have to outsource it and wait 3 weeks between iteration cycles. That was the original, and spending so much time in a machine shop, you just know that, like, even if you have a CNC or a 3D printer or both, you're still spending a ton of time hacking sheet metal with a bandsaw or an angle grinder or a Dremel. So it was just intuitive that there was a core digital tool missing from the shop. And so that was the original problem. But with as we've grown and entered the market and started talking to customers and selling to customers, we quickly realized that it's much more than just that. There's a lot of other use cases and applications. Our class just being one of them.
Yeah, definitely. And so, I mean, you guys, the original goal was more around sort of democratizing it and getting it at a price point to sort of enable more mass pickup in that. Because, I mean, anybody can go out and spend a couple $100,000 on a, 6x8 Waterjet machine if they've got the space for it. But
yeah, so it was an accessibility goal, and accessibility means a couple of things in my mind with water jetting, but it's primarily price. So getting the price down to a level that people can afford, small businesses or individual entrepreneurs, and then also certainly space requirement and ease of use. So just the whole package of accessibility.
Yeah, that's great. And I think being able to come to market, luck has everything to do with it. Timing has everything to do with it. So you guys, it was a senior project that turned into a Kickstarter. And how did you see Kickstarter being used? I mean, some people love it, some people hate it after being successful there. Did you guys see it as a marketing platform or a funding opportunity, or really just like an alignment of customer expectations or kind of gauging the market viability?
Yeah, it was a marketing and funding opportunity. Okay. I would say, it did provide us with necessary capital that we didn't have. We didn't go and raise a huge, Series A prior to that or subsequent to it. We raised a little bit of outside capital, but so it was certainly that, and it was certainly a way to amplify our message and get it across, to spread it to a wide audience. And we certainly did our fair share of marketing, on top of just the Kickstarter. And it's hard to know who found out from where or whatever, but the totality of it was that we got a lot of awareness, and it was not like we like sort of moderately went viral. Right? We got enough eyeballs on it that we had a big splash. I think we did, 500,000 in the first 24 hours or something. So it was there were a lot of people that were really excited to be the first ones to get a Waterjet.
Yeah, that must have been an exciting 30 days for you and your team.
Yeah, it was wild, and then 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 it's back to work, and the interesting thing is, and this is like, I mean, now I think this story is more known, but even at the time, we were, okay, we can't promise like 6-month delivery. Like we're not stupid, let's say 12 months, so that we really give ourselves enough time. And of course, it wasn't even 12 months. It was almost 2 years. It was about 20 months. And it's just so interesting. I mean, the machine looks the same as what it did in Kickstarter. It really was a true looks like, works like prototype. But getting it from that to,
production,
volume production is just a totally different ballgame. And it's hard. It's much harder.
My rule is think of the longest time you could even fathom some project taking you, and then multiply it by 3.
Yeah, right.
That's my internal mental rule for project timelines. So successful Kickstarter, and then what were some of the, not gory details, but biggest hurdles maybe of sort of the next 20 months that you talked about? Getting into production? Was it sourcing some parts, or actually finding, a compressor that fit within the build volume and still calling it a desktop? Or like, what were some of the biggest, I guess, product challenges that you guys overcame in that fulfillment stage of the first 20, we'll call it 20 to even 30 months, because I'm sure you're still dealing with some of that after you rolled it out.
Yeah. So, There actually wasn't one core problem. So I'll just say sort of like a category of just the sheer volume of parts. It's the bill of materials is in 400 or 500, and the number of suppliers that we directly manage and speak to and source components from is also north of 100. So, and that's the only way to make an affordable water jet is to go directly to the source, and find components part by part and put it all together. And so doing that 100 times and, making the drawings and getting the samples and then measuring the samples and figuring out where critical tolerances are and things are not matching, and then communicating that back to vendors, and then getting the first production batch, and then that not being the same as the samples, and then just doing that 100 times. It's a lot. It's a lot of work, and there's no way to make it go faster in many cases.
Absolutely not. Well, and certainly, I'm sure at that point in time, you guys were trying to make financial versus quality good decisions on different suppliers and places to get things. Those are always in total conflict with each other, but there's no fast button.
Yeah. So that's why it took time, and we ended up doing a lot of it ourselves and kind of have that DIY mentality, as a lot of colleagues in our space do. So we actually did the final assembly, and we still do the final assembly. So we were doing it in our facility in Brooklyn, New York at the time. So we were assembling the machine soup to nuts, and that was proved to be really valuable because our engineers could oversee that process and recognize if there were any issues and be able to debug, diagnose, and fix the problem. And we never had any kind of large-scale quality issues, and the first machines that shipped out, they worked. We've made improvements over time in quality and consistency and things like that, but the original machines work and are still in use today.
Testament to a good design that's long-lasting. Yeah. Well done. And so tell me about your current product line today. And I think that's really cool that you guys have been doing the production final quality testing in the US. That's like such a rad story. But the machine's capabilities today, what's the Wazer portfolio look like for someone who's not familiar with it?
Yeah, so we have one main product, and then it comes in two power configurations. So we have the main sort of desktop machine, the Wazer machine, and you can get it in North America for 110 volt 60 hertz, or you can get it in the rest of the world in 220 volt 50 hertz. But it's the same machine, and it's a 12 by 18 inch cutting area. So that's the largest sheet of material that you can load into it. And it's got a 2-axis gantry system, just like a laser cutter, with a manual adjust of the Z to accommodate for thickness. And it'll cut through any material, and it's just the maximum thickness and the speed are both highly dependent on what you're cutting. If you're cutting the harder the material, the slower it cuts. So the machine maxes out in stainless steel at about 1/8 of an inch, and maxes out in foam at 1 inch thick, and kind of everything in between. So really runs the full gamut. Maybe I'll just also back up and kind of explain how waterjet cutting works. For folks that aren't familiar with that. So the machine and waterjet in general. So you just take a regular tap water source and feed it into a high pressure pump, which is powered by an electric motor. And so that high pressure pump pressurizes the water, and that high pressure stream gets fed through a nozzle, or actually it's called an orifice. So it gets fed through an orifice, a small hole. And so now you have this like really thin stream of high velocity water. And that stream creates a suction that sucks in the abrasive particles. And so the abrasive particles are called garnet. It's a naturally occurring mineral, and the mixture combines and then gets focused in this mixing tube, and so ejects a slurry of high velocity water mixed with sand, garnet, and that's what does the cutting. And so if you attach that cutting head assembly to a 2-axis gantry system, all of a sudden you've got a way of cutting any sort of arbitrary 2-dimensional shape controlled by a computer.
Yeah, I think that's so cool. And to be able to understand that water is just the medium for which to throw garnet or, sand at this thing, and have the sand abrade it away. But what's the water pressure at for the Wazer system?
It's 4,000 PSI.
Oh my gosh. Yeah.
So that's high, but it's also, it's low in the industrial water jetting world. Is typically runs at 60 to 90,000 PSI. But really the more important parameter is the total hydraulic power, which is the pressure times the flow rate. So it really matters how much water you're shoving through the nozzle, not just the pressure or the velocity of it. So we're running at 1.5 kilowatts of hydraulic power, which basically just maxes out a regular 110 volt outlet.
Right.
So you could run this off of, if you only you can run the Wazer off of a standard 110 volt 15 amp circuit, and that was like a design constraint. You plug it in, and it'll pull like 13 or 14 amps, and you actually need to plug the controller and like the desktop machine into a separate circuit.
Oh, gotcha. Yeah.
Right. And just the pump will basically max out a 15 amp, or you can use a 20 amp circuit, and then you can plug both into the same one, which is like most shops have 20 amp circuits. But yeah, so that's what it takes to run it, and it's pretty amazing. Water is the medium, and you're just accelerating these abrasive particles, and the material removal method is micro erosion. So it's eroding the workpiece, the material away, one small particle at a time, just by rubbing the garnet into it. And what's cool about that is, first of all, every material erodes. Literally every material. And there's no heat. There's no heat. And there's no loads either. So it's really unique in that way, and that like lends itself to being able to uniquely cut virtually any material, which other material removal methods just don't have. If you're using conventional blades in a CNC, you're limited by the mechanics and the dynamics of the blade as it cuts into material, and laser, optically you're limited, and plasma, electrically you're limited, and water jetting, there's no limitation on the material. Like, it will cut everything.
Yeah, I think that's the, it is the answer for many applications. And I think some people don't think about that. And I always just think, sort of as I mentioned, like, what's the next tool that I need to add in my shop or in my garage as a user, a hobbyist, or a small business owner? And I think very often the answer, especially if you're doing sheet metal or if you're doing glass artwork, as you said, there's no other way other than scoring with that knife and then doing the crack. There's no way to get dynamic shapes. Glass erodes. Throw some garnet at it, some abrasive, pile it in with water, and they're not. I guess it's a little bit relative. I think, from my perspective, it's a really inexpensive way to succeed there. Rounding numbers, $10,000 to get the full system. You're saving a lot of money compared to any other option out there for water jetting specifically. And the tool as it is adds so much more capability to a workshop. small
Yep.
business. So Wazer being that answer is so cool for many applications.
Yeah, and a lot of time the alternative or the current method is one that is very manual and requires lots of steps, and so the savings and the ROI are really obvious in a lot of cases. And looking at that, and also just going back to the uniqueness of the material removal method and how it so allows for so many things. So it's not just raw material; it's the ability to cut some sort of pre-processed material where you can't just you can't substitute, you can't print a look like or works like. I'm holding in my hand now just a simple dog bone sample, but this is actually, there's a laser weld here in the middle, which you might not be able to see, but so this is actually cut out. This is a standard dog bone sample that you would put on an Instron machine to do tensile testing, but it's actually made out of two pieces of sheet metal of different thicknesses that were laser welded together. And so we found that that's a pretty common use case, and we get a lot of inquiries of like, hey, can you cut dog bones in this material, or we need to inspect this weld. Well, you can't, you have to cut this weld. You can't you can't print,
can't fake it.
You can't fake it, right?
Yeah.
So and you have to do it in a way that doesn't damage the integrity of the thing that you're testing. And so if you're introducing heat or vibrations or other things into the material that you're cutting, you're screwing with your test.
You're putting noise into the system, that's for sure.
Yeah. We spoke. I spoke recently with somebody at NVIDIA's failure analysis lab, and they're when a video card or what our graphics card or whatever they're looking at fails, they want to understand why it failed, and oftentimes that involves literally cutting through the whole board and the whole piece to open it up and inspect something on the inside.
Yeah.
Well, how do you do that without crushing circuits and creating a whole bunch of other stuff that wasn't part of the failure? And so he's using Wazer to make to sever these boards and be able to inspect them.
That's such a cool application, and so so wild to think of. When you showed that dog bone of the two thicknesses of material laser welded together, I just think of the automotive applications and all these kind of battery packs in EVs that are coming to life. They've all got different thicknesses because that battery pack in some cases is being used as the floor and the whole, it's like a structural piece, so it's got a thick exterior but then a pretty thin in the middle. And I know that they're doing exactly that. They're like, all right, well, this is the production sheet we made. Now we need to test the weld, and exactly as you were talking about, if you can kind of, hack that out and just do a pull test, that saves a lot on the, kind of not having to inspect it using some other X-ray methods or something like that. Just, cut it out.
Yeah. And a lot of these automotive suppliers we're talking with, it even tier ones, their current production quality control method is to bandsaw these parts. And inspect them. It's crazy to think, but this is not just that's the thing going beyond kind of prototyping and just rapid iteration. This is a continuous part of production process that never stops. Is QA QC every batch at every regular interval, to whatever it might be. It could be every shift or it could be once a month. These manufacturers need to cut out samples and inspect them and to ensure quality. So it's pretty cool to get it. That's
I think your NVIDIA and the automotive use cases are some of the coolest. Who's your key customer? Who did you invent this machine to kind of target, or has that evolved over time? Who do you think is a key customer for Wazer, someone who needs a desktop-sized Waterjet?
Yeah, so it definitely it started out, as for engineers, that are designing hardware equipment in the rapid prototyping, sheet metal mainly use cases. But it's quickly evolved to be broad enough that we don't have a main customer. Manufacturers of any sort of hard goods, whether they're equipment manufacturers or component manufacturers, pretty much it runs the gamut. Those as a group are our main customers, but the use case is just depending on the specifics of each company. It can either be in the engineer's realm for prototyping, or it can be on the production, by the production team for things like QA or tooling and jigs and fixtures and things like that as well.
Yeah. Yeah, I think I've been impressed just kind of listening to the MatterHackers sales team and the conversations they've had. I know there's a lot of the breadth is wild. Just somebody looking for one of these to shove in their garage to, again, sort of expand their capabilities of what they can do in their shop. And I know we've also had, successful sales to Northrop Grumman and some aerospace, some military, some sort of automotive. Like all of those have been customers that we've seen a lot of traction. And it just surprises me how broad it is.
It's so broad. It surprises me, and it makes it very difficult for me to answer that question. It also makes it hard for, as a business to figure out. Business school, business 101 is, focus on a niche, and really solve one problem for one customer group. And we can't, as much as I've tried to do that and to categorize people, we can't do that because we have a universal tool that's just so widely needed. It's like it's the 21st century version of a bandsaw. I mean, every shop has a bandsaw and a drill press to do your basic fabrication. And in 2023, that should be a digital tool, not a handheld or manual tool.
Absolutely.
And so we see the same breadth, both in industries, whether it's from aerospace to a stained glass artist, and we see it from single person businesses, garage businesses, all the way up to enterprise, and Tesla, SpaceX, and that breadth in the same industry. Like also in aerospace, like we sell to a 10-person startup that they're making they're making a thruster for CubeSats. So they're making like this thruster module that you can attach to these cube satellites to be able to then in space change the orientation of the satellite. Pretty wild. And so startup company just doing prototyping and need to be able to fabricate parts quickly and iterate. Like for them, it was a no-brainer to get a Wazer.
If it fits in the build envelope of a Wazer and you can do your own water jetting in your shop, go do it. Because I think of it as kind of like sort of two options. Let's just take this, this small shop of 10 likely engineers that are making prototypes for a CubeSat, right? They either didn't think of water jetting and it wasn't something, so they were going to grind this or, chop it in a big scissors or something like that to get their sheet metal part. So it expands their capability to be more detailed and more aligned. The other case that I think is really interesting, and this is the parallel to 3D printing. All right, so I worked in medical devices for 10 years, and I know that we had a 3D printer in the machine shop. Good luck. Wait for 6 weeks to get in line, right?
Totally.
And if somebody does have, maybe you're a big automotive and you've got, maybe you've got 3 or 4 Waterjet tables, big, huge industrial ones, but there's still this line. Aren't you better spending that? I don't know what an actual big industrial Waterjet, let me just guess it's $100,000. Would you rather have one of those and wait for a few weeks, or would you rather have 10 lined up that people can build? If the build envelope fits, and often it does, I'd rather have 10 of those that engineers can individually use.
And 10 of those in different groups in different rooms of the same building or in different buildings of the same complex. We hear that all the time for our large customers, like, like a John Deere, like talking to their engineers, like, why are you getting a Wazer? Like, don't you guys have like the best, machine shop equipment, prototyping? Yeah, but it's impossible for us to get time on their prototyping lab. And it's not even like it's not even like ability to get time on their production machines, which of course are kind of out of the question. Yeah, just to get time in the prototyping lab that's supposed to like solve the problem of, not having access to rapid prototyping, but it's not those shops are not equipped with the right tools, and for large companies that have independent small engineering groups, like, they need to each have their own prototyping lab.
Well, and it comes, I'll just go back to our, 20 minutes ago in this conversation, 30 minutes ago in this conversation, accessibility, right? Someone who's you've got some machinist or a well-qualified technician to run the large tables as is appropriate. But with a Wazer, kind of any engineer can sort of step up to it and succeed.
Totally.
Right?
Totally. Yeah, exactly.
And I
that's
think
what it's designed for. And it's also, it's one of the advantages of 2D. It's just, it's so much simpler to, the time it takes to go from, drawing to physical part is just really condensed, because there's, our software, our slicer equivalent, there's not much to it. It's just 2 dimensions, like select your material.
Vectors.
That's basically it. Yeah. So,
so the details of I suppose the equivalent of feeds and speeds are all preset in your software when you choose a material.
Yeah. There aren't exactly. There's the feeds and speeds are based on the material and the thickness, based on a pre-calibrated library of materials that we put together. And then that ship free with the software. And then, of course,
Profiles.
You can add your own material.
Gotcha.
And, if you need to, and we have like a protocol that sort of walks you through how to do that and how to like figure out what is the right speed for cutting this material.
So let's say we've done our job here and convinced someone that they need a Wazer, desktop-sized Waterjet capabilities in their shop. Most people listening to this podcast are already very familiar, extremely familiar, even experts at 3D printing. What's the hurdle that they're going to encounter when it comes to purchasing and receiving the Wazer?
I would say the breadth of materials is like the performance, the edge quality, the finish, how an inside corner or outside corner, how those materials behave, varies quite a bit from a brittle glass to a ductile aluminum to
Definitely
a thick piece of metal to a thin. So understanding like what you're expecting to get out right at the end. I think that's also a big thing in 3D printing is understanding really the details of it. When I have this CAD model, when I send it to a printer, what it's going to look like when I come out, like all of those things, like the parallels exist, but there's an infinite set of materials.
Sure.
So,
and just
3D
dialing
printing
in
has the dialing it all in, knowing what to expect, what sort of post-processing you need, depending on what your application is.
And I think even your protection here and saying like the tough things, I think it's tough. As we have one here at MatterHackers. I've used it many times now, and it was really easy to set up, easy to get started. The hardest part was actually getting used to, as you were talking about, like how different materials behave. Most users are going to like have their 1/8-inch aluminum and just kind of that'll be their thing, or carbon fiber. So dialing in for specific materials actually comes really quickly. Yeah. But every time you start with a new material, you got to recalibrate that dialing in process of what you're used to. My biggest surprise was called a Waterjet, this technology, but really you're using the abrasive, right? So you go through a lot of abrasive when you're at that much volumetric flow rate through that orifice. That was my. It plugged into the wall. The software was easy. The materials were easy. You're like, oh wow, I went through a lot of material real quick.
Yeah, it's a lot of abrasive. We try to manage those expectations, and we sell a bundle. MatterHacker sells a bundle, the starter bundle with the full system plus a full pallet of abrasive, which is 2,200 pounds of abrasive. So just for people to get us, understand the scale, like that, you sell that because that you expect to use that amount.
We genuinely sell that sort of at cost. It is a consumable, but we just try to enable people as much as possible.
Yeah, it's not filament. It's a high weight, low volume. It's a commodity, but it's not something that's a big moneymaker because it's half the cost in it is shipping it.
Dude, so it's crazy. So what are you most excited about as we wind down this conversation? What are you most excited about next? Like what's Wazer working on? What projects are you seeing that's exciting? 2023, what's coming?
So we see we see a big opportunity in the accessible waterjet space, and certainly we're not going to solve right now. We have this one generic machine, but there's you're certainly not going to solve everybody's problem with one generic machine. That has whatever limitations it has. So we're really excited about the opportunity to continue to innovate within the waterjet category, which is something that nobody else is really doing right now.
Absolutely.
And so that's exciting for us, but I think it's also, we've got a big kind of awareness building, an educational challenge ahead of us. We saw we knew that there was an opportunity, and we certainly did ride the wave of the emergence of desktop 3D printing, but on the flip side of it, I think that huge wave has led to hundreds of 3D printing companies all kind of marketing for each other, and it became it became additive manufacturing as a thing, as a phenomenon. Just the awareness to every engineer was pretty quick. But water jetting is still not very well known in the broader market. Because its history is like a niche manufacturing process for automotive and aerospace and very specific applications. And so what we're trying to do and what we are doing and what we will continue to do is to show all of the different ways that this technology can be used, and it's infinite. And the way we do that is by telling customer stories of how they're using the machine, and so that when people hear about us, they can relate.
Yeah, I think everybody's looking for an example that's not their exact example, but an idea that they have that they're one tool away from succeeding at. And I'm just blown away, whether it's a desktop CNC machine or a desktop waterjet machine, someone doing, like you mentioned, glass art or some sort of 2D geometric cutout, that they're just looking for a case study that reminds them that they can be successful. And I think Wazer's, successfully brought to market a product and a tool that someone can use to create a new company or enable a Fortune 500 company to work faster or gain higher qualities of the outputs of their products. And I think that's really exciting. So MatterHackers will do our best to continue to tell your and the team at Wazer's story, because I think more people need to know about these types of products.
Awesome. Yeah. Thanks, Dave. Really appreciate it. And it's been great working with you and MatterHackers.
Yeah, I appreciate it. Well, thanks for your time today. Really appreciate your time, and I'm excited about everything you guys have done. Heck of a story. We're excited to tell it and shout it from the mountaintops, and look forward to everything that you guys got coming in the new year.
Awesome. Yep. Likewise. Happy New Year. And yep, best of luck in 2023.
Cool. Thanks, man.
Thanks.